Okay, if you haven't been to Awesome Framers, that's Tim Euler's YouTube channel, you need to go there and just every night watch 3 or 4 videos because he is probably in the top 5 best framers in North America. Easily. I used to think I was in that group, but then when I saw back in 2006 when Tim was writing for JLC, he had learned how to do those curved brows, those eyebrow things, and I knew right then. I was like, "Oh man, he wins." Yeah, I used to be on that JLC forum with some insanely intelligent roof framers, and Tim was one of them. There was Joe Bartok and Sim Ayers. Trying to think of who the other ones were. I don't use their names enough to remember, but anyways, so he started a video, and I hit brakes on it because I was like, I want to see how I would have done it compared to how he's about to do it. So I never watched the whole video. I just know that he had a structure that was 40 feet long, gable on one end, hip on the other, 6 and 12. So if I was going to do a line drawing, and I'm using Chief Architect right now just because. Yeah, we'll do that. So there's a line drawing, and then jacks. I'm sure he's going to go 2 feet on center because that matches trusses and stuff, but I'm older than he is, and so I do 16 on center. So there. But anyway, so there's what it's going to look like. 6 and 12 on both of these sides, 6 and 12 on the end. This line really here would be like that. If you were doing like a roof layout, that's what it's going to look like from the sky. So he used SketchUp right off the bat. And I'm going to just do a 2D version of that here in Chief Architect and then go from there. So let's do this. Let me do some. Chief's kind of weird. AutoCAD is really easy. It's just lines. But Chief's going to be interesting here. Let's see. We'll do 1.5. Yeah, so this will be 2x8 rafters, 2x10 hip and ridge, maybe even 2x12. We'll see. See, that's not even where I want that. I want that to go right there. So I can get rid of this. And yeah, we'll go ahead and use the same material. Sometimes people will get kind of smart and use LVLs or hips, LVLs for valleys. Especially valleys. Valleys are weaker than hips. I got to turn off this line thickness. It's just crazy. And we're going to break this line here. We'll go like this. We're going to detach that so that I only delete that. Let's try this. Oh, you know what? I might as well finish it off down here correctly. We're going to go here. We'll copy in place. And we'll come in tab. We'll make these all 2x6. So let's do some talking about that while we're here. I just ran across someone who measures to over sheathing. Man, I have never done that. That doesn't mean that the way I'm doing it is right. It just means I have never done that. Because sheathing can change. Framing doesn't change. Face of framing, face of framing, face of stud, edge of concrete. I've seen some people that want to have their framing inset so that their sheathing is flush with the outside of the concrete. So their siding has a nice tight finish up against. I've seen that. A lot of it on slabs and stuff, but I've never seen people actually dimension to over the sheathing to do their roof calculations. And let's see, what are we doing for let's copy this in place. And we'll come out here, tab let's make it 20 inches. And on the eaves, they're typically less. So we'll go tab 14. Tab 20. Tab 14. Oh, you know what? Duh. This is a hip, so this will be tab 6. So yeah, that should be 20 all the way. All right. Yes. Yes, sir. And that's the outside of framing. So what I'm going to do is copy and place one more time. And we'll come in tab 1.5. Okay. I feel compelled to just ramble on, but maybe I shouldn't. Let's see if this works. I'm going to trim this. See what this does. Yeah. Okay, good. And that broke that, so I'm going to go ahead and rejoin it. Okay. So let's fill it with like just the slightest little bit of solid. We're going to make these red, but almost transparent. Because I've used LVLs that came out pink. And this isn't an LVL, this is only 1.5 inches. But I want to have some of this differentiated so it's easy to see. Now I'm going to copy and place and reflect about that. Boom. Okay. So now I've got 2 hips. We'll make the ridge some kind of solid. Let's make it blue. I don't know, just because. And we'll make it, I don't know, like 75. All right. It looks like almost like a Panamanian flag flying to the opposite direction. What do I know? Okay, so what you need to know, most of these dimensions you're going to see here are going to be horizontal. You know what I mean? They're going to be, let's see, text. I need to make this big enough we can see. The dimensions are not going up the rafter or up any angle. These are all horizontal for now. So the building is 24 feet. And I believe he had said it was going to be like 40 feet that way. Okay, good. So what you have to do is you have to take this is called the span. Whenever it goes over the outside of framing to over the outside of the framing, and you're trying to do a roof, that's your span for calculating. If you are running joists, the actual span for a joist is where it's no longer supported, and that would be on the inside to inside. And when I started down in Texas, and we had 3.5-inch walls. And so a lot of times, if you're familiar with framing, there's a bird's mouth with a plumb cut and a seat cut. They would make the seat cut whatever it took for it to come over to the inside of the wall, so that you'd have the maximum amount of the rafter sitting on the plate. Well, you can't do that with a 2x8 or a 2x6 if your wall is 2x6, because it's just too wide. You'll cut most of the rafter off. You won't have enough meat to hold the tail out there. And there's another thing that I had someone question. Yes, one rafter from the ridge out to the subfascia, but it has two components. It has a calculated rafter component, and it has an added tail component. And so what you do is you do all your calculations over the things that you know, like you know that you're going to have a bird's mouth at the outside of this framing. And that's how you get that measurement. And you make a mark on your rafter at that point so that you can cut this angle. And then for the rest of this, you create a tail pattern. Or if you're like Tim, he'll just get out a chainsaw and have everything all bundled up, and he'll just one cut 50 rafters. Well, maybe not that many, but quite a few. Yeah, he's pretty impressive. I don't trust myself. I would get off, and then I'd have rafter headaches. But yeah, you pull down to here, you make a mark, and you apply your tail pattern, you trace out the rest of it. And that's what you do. And it's not hard. It's not bad. Once you get into a rhythm and you understand what you're doing, the hard part is when you get into really complex roofs where you have hips that are going down to valleys or ridges down to some kind of thing and then over to something, and you have to figure out all the different parts that go in there. But what's amazing is you can calculate all that. So you don't have to go up there and measure. If your guys built the building to the right size, you can bring in the perfection of a calculator, or like in this instance, a computer, and all these lengths will be mathematically perfect. And then I've had guys, it was kind of funny, because you have to string these straight, these hips or valleys or whatever, ridge, all of it, just to kind of make sure you're putting your jacks in correctly and not causing a big bow that'll be seen through the shingles. But I also like to lay out the hips with a plumb line at whatever that diagonal is between each rafter. And then I can tell the guys, start in the middle, put your jack down here, and then slide it along until you reach the layout and put a nail in it, tack it. And then come from the other side and do the same thing and do what you got to do to get this to where it's on the layout, and then tack it, and then go look. It should be straight. Because what you're doing is you're cutting to theoretical perfection, and you're forcing that perfection every chance you get. You're forcing it to be where it's supposed to be. And the only problem is sometimes you get lumber that's, got variations in it, but the variations go both ways, so they kind of average each other out. But anyway, so here's your 24 feet. What you do is you take 24 minus the ridge thickness. So this could be a big structural ridge, 3.5, 5.5 wide, whatever. You take the span minus the thickness of this ridge, which happens to be 1.5 inches. And let me do this. Let's see what this looks like. Boom. Holy moly. I wonder if I got build calc on here, because I like that one too. So you go 24 feet minus 1 inch, 1/2 equals, divided by 2 equals. So there you go, 11, 11 and a quarter. I'm going to keep losing this behind the screen, so I'm just going to pull it off here for a minute, and we will do a dimension real fast. Okay, there you go. Now it's time to talk about feet, inch, and 16th. I might as well just leave that alone. So feet, inch, 16th. So that would be F, 1, 2, 3, boom, 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 I, S, centered. And then we could do this. 11. Four. So let me take some of this out of here. All right, so if you see that, feet, 11 feet right here. Let me make that there. 11 inches, and then a quarter. So it's 11 and a quarter. And a quarter is how many sixteenths? That's 4 sixteenths. So the only reason I bring this up is when you get trusses delivered, the truss software typically does their measurements this way. It's a 1x3 matrix, 11, 11, 4. So you get used to seeing different ways to do lengths. And this is a super efficient way. Like if I was to handwrite this on a block and I went 1 apostrophe dash 1 space 1/4 quotation, that's a lot of writing. Where I can just go 11-11-4. So I've got the people that work around me have gotten used to this, and we don't have to, what's 13 sixteenths? I don't know. It's 13. Just put a 13 right there. You know what I mean? Because some people are scared of those really small fractions. I don't know what the deal is. But anyways, so there's your run. So we're just going to double click this, and we're going to add the term run. So there we go. 11, 11 and a quarter, or 11, 11, 4 is the run. And then all we need is the pitch, and we can figure some things out. Now I want to show you something. I'm going to just draw down to here. I'm going to make this 1.5 inches. We'll fill it with hatch angle 0.5. Let's try to see how that looks. Boom, there we go. So there's the horizontal length of the rafter and the tail. Oh, that would be cool. I could make that happen. I could go like this. And then copy and place. Point to point move. Come down here. Double click. Change this angle 90 degrees. Go right there. There we go. So now technically we have one long board, but it looks like it's bent. But anyway, so there you go. Had a 6.6 earthquake just happen somewhere on the planet. And then I don't know if I'm able to group these. I think I can. I think I can block them. Yeah, there we go. All right. So there's the horizontal length of the whole rafter. But here's where I'm going to calculate, and then I'll even go get pictures of my my typical tail pattern. But what I wanted to show you is I can go copy V and then rotate this. And we move from there to here. And look at this. So what that tells you is these are all common rafters. And when the pitch is the same all the way around, you get to use one of these commons as an end common rafter. And that's what sets the location of where your ridge starts. So this would be where you're going to want to have, I don't know what's below this house right here, but you're going to want to be able to put some vertical bracing in down, not just onto a couple joists. You're going to want to have it onto a wall. And there's not a lot of roof load. There's some. But it's not like people that panic and they go, "Oh, but you got to point load that all the way to like a footing in the ground." No, it's not that heavy. That it is important, but you can actually, if there was a slab on the ground, you could actually point load, and maybe if there was an opening here, you could put a header across and then bring that load down and just sit on concrete, because we do that all the time in Texas in the South. And unless you're going to have like 50-pound snow load, that might be a problem. But there's other ways around that too. You can put beams up in the ceiling. There's all kinds of ways you can mitigate load, get it out to the outside walls where they're designed to hold all that weight. But anyways, I'm getting out of whack here. So now that we've got this, what I'm going to do is unblock. And I want to multi-copy 16 inches way off in the distance. I hear either fireworks or somebody shooting. Okay. I'm going to trim, and watch what happens when I trim. It's going to, all the fill is going to go away. Boom. And it trimmed to the wrong side. Oh, you know what? I got a way to fix that. Watch this. Z. Okay. Since this is an actual polyline and it decided to pick it picked the first thing that it touched. What you have to do is start here and just draw a line. It's nice that it's on a 45 because the default settings in this app are every 7.5 degrees, I think. We're going to trim. We're going to come back and go like this. Okay, so now what I need to do is connect all these. And then their hatch or fill. It's technically a fill. I just happen to choose a hatch pattern, but it is a fill in chief. I believe this would be considered a hatch in AutoCAD. And I've tried Soft Plan and I've tried Solid Builder. I am not happy with Solid Builder. They only support the current version. They always try to have you buy some $2,000 next version. And so if you own an older version, they don't care. It's really a bad model. I have no patience for them. All right, so now we're going to do this. We're going to pull the tape over this one to this one. There you go, 16. So these are all 16. And now what we can do, let's just confirm the horizontal length of this. It should be the same, right from there to there. Yep, so it's the same. So now what I'm going to do, and this is where it gets interesting. If you do the construction master and you tell it to do your jacks, they're going to be wrong, okay? And the reason why they're wrong is they do their calculation off of a center line, and they make the assumption that they take they don't take the thickness of it. They go from the face, okay? So when you get a run, you're coming from the face of this ridge, and the thickness of that is 3/4. That's half of the thickness when you're perpendicular to it. But when you come in at an angle, from the midpoint of this hip over to this point is more than 3/4, okay? But they go from the face and they just assume, okay, we're going to take off that same amount. And so when you see what I'm going to show you, you'll see that you can't just trust your calculator. And the only reason that I stumbled across this was I would get so frustrated because I thought I was doing everything right and that I was a badass framer. And I would use the Construction Master. And as I got closer to these smaller jacks, they would be they wouldn't be true. Like when you go to run the plywood sheathing, it wouldn't go up the center. These would be a little bit out left or right. And I kept going, how in the world? I know I cut these exactly what the calculator said, but they're not going in straight. And then I thought, well, maybe my hip is bowed or something. No. So I had another calculator, a HP50, Hewlett Packard HP50G. And I wrote my own equations to figure this out. And I used AutoCAD to make sure I was right because I couldn't take this. You know what? It really doesn't matter if you really want to be honest. So you're off. Let's say it's 3/4 to the right or to the left. Your plywood still sits on here. Or you know what else you can do? You can just scab on another little rafter on whatever side you need to have the support, nail it in, and you're done. But that bugs me because I don't like scabbing. I don't like having to cheat, even though I'm following the truth of this machine, and it's sending me down the wrong way. So here's what we do. To proof this, you have to measure from the long point to there. And, I may end up shrinking these down a bit because that's going to get kind of big. And like I said, this would have a tail pattern. So whatever this needs to be, like if this is almost 2 feet, so when you order lumber, once we get these rafter lengths, I will show you how to do that too. So let's just do 3 of these so I don't waste everybody's day. You get the idea. Okay. While we're here, let's go ahead and dimension how far the horizontal length is. 18.5. Yeah, you know why that is, because we said that it's a 20-inch overhang from framing to over subframing or subfascia. So that would be right. 18.5 horizontal. Okay, so now we're going to take out this handy dandy calculator here. We're going to call that run because that's what that is. We're going to say the pitch is 6-inch pitch. Drum roll, please. Diagonal. 13.4 and 3/16. So what that means, I'm going to have to come up with a new way to do this. And I lost. I can't have that. I'm going to have to put that over here. So we're going to come up with a numbering scheme. We're going to make you 3. And we're going to make you, let's go with this color here. And we'll make you also, okay. So where did here it is. 13.4 and 3. And it's 3 inches. Boom. Okay. And I'm going to make that to be filled so that it... Okay. 13.43 to there. I don't want there to be a right space. I don't want there to be... Actually, really don't want there to be any of this, so let's try that. All right, 13.43. So that's the main, that's this right here. 1343 to there. And then the tail, we can just calculate that right now. Excuse me. So then we go clear, clear. Where is that? 18-inch, 1/2. Run. 20 and 11/16. So that's going to be kind of interesting because feet inch 16th, I'm going to go 1 is 12, 8, and 11. So that's 20 and 11/16. Make sure that that's what it is. 20 and 11. Yep. I could convert that to feet, I suppose. Yeah. 1, 8, 11. There you go. And let's move this. Okay. So there's the rafter length. And you know what we'll do? We'll just make the tail length a whole different color because I just don't want to get too confused here. And we only need that rafter length one time because we're going to take these, the tail length. This rafter length, they're going to sequentially get smaller and smaller. And the tail length that we add is going to be from a static tail pattern that doesn't change. So there's that. Oh, and while we're here, let's do this too. Let's go point-to-point dimension. Well, okay, that's the highlighted app. Now this is the foreground app. We're going to go from here to here. That's the horizontal. Dimension. And this always happens, man. My throat starts getting stupid. That's just a placeholder because what we're going to do is we're going to go clear, and it does hips correct. So I can go 11 foot, 11 inch, 1/4. Run 6 inch pitch, hip valley. So this number, son of a gun, man. 17, 10, and 7/8. All right. 17, 10, 14. So that's the angled length of that hip all the way to there. But in reality, I'm going to actually cut it all the way out because when you have a common overhang or common pitch, I guess, and the overhangs are the same, then you might as well just cut that hip with a tail that sticks way out there to help support everything. So instead of just stopping here, I would stop here and I would make the appropriate bird's mouth, but then I would carry on and have my tail come all the way out to hold the subfascia. So we can do that. I wonder if it'll let me do this. Yeah, hold on. Because really, people will say it's 17. It's 6 and 12 for your commons and 6 over 17 for your hips. But it's not really. It's the square root of 288, which is 16.9 something. And I'm used to my actual HP calculator. I wonder if I have that on here. What is it? EMU? Yeah. This bad boy. But this doesn't have any of my equations in it. It's just, it'll do whatever I need it to do. So that might take a little while. But let's go ahead and go back to the original 11. Oh, no. That's not what I want. I need to know what the run is from the face of this out to the face of this. Oh, come on. There's one of Chief's little hang-ups. There we go. Okay, so that's my new run. Where did that go? Where did who go? CM, boom. Okay. 13 foot 5 inch 3/4 run 6 inch pitch hip valley. So the whole board 20 foot 2 and 5/8. Boom. All right, so there you go. Yeah, if I'm going to do that there, I might as well do this here. Keep them uniform. Mayday, mayday. Okay, so we've got that rafter. So now let's do this. I'm going to let let these guys, Construction Master, do the jacks. And then you're going to see the problem. 11 foot, 11 inch, 1/4 run, 6 inch pitch. And then all of these. There's your rafter, 13, 4, and 3/16. We got that. Let's do jacks. We're doing jacks 16 inch on center, which we have drawn here. And I'm going to copy this, and I'm going to do it in I'm going to pick some kind of wild orange color, because this will be, well, we could do Construction Master yellow. Why not? Hopefully you can see this. No? Okay. We'll go back to orange. Let's move some of these. And we're going to multi-copy this, 16 inch, yes. And we will just go ba-da-da-da-da-da. And then we're going to start with this jacks. So we're going to hit jack again. Your increment 1, 5, and 7/8. So let's write that down somewhere, because that's important to know. 1-5-14. And that is jack increment. Okay. So now we'll go back to this. We'll hit jack again. So it's saying the first jack is 11, 10, and 1/4. 11, 10, 4. The next jack is 10, 4, and 3/8. Ten, 4, 6. And we'll do one more. The next jack, 8, 10, and a half. All 8, 10, 8. Okay. So now that's what Construction Master is telling you. These are the lengths of your jacks. But we already know the true horizontal length. So let's actually run these and see. Let's move that, because I don't want anything hiding and somebody going, yeah, well, you hid something. I don't care. Oh, man. Yeah, so let's do this. Let's go 10 feet, 7 inch, 11, 16, run, 6 inch pitch diagonal. 11, 10, and 3/4. What do we got over here? 11, 10, and 1/4. So somebody's wrong. So let's do this then. Let's do copy and place. Move these over here. No, you know what? We're going to move these up here. And we're going to go open them up, and we're going to go with some kind of cool looking green. What is that, clover? Let's do clover, because clover is going to be the right numbers. And we'll go back here. So this is 11, 10, and 3/4. Wow. So that means that that's 12. So then if it's, that's a 1/2 inch difference. So then this should be 14. I'm just going to go ahead and play risky here. And this should be, plus 8 should be 11-0. Let's see what happens. I'm just curious. I was like this in school, dude. I couldn't take a test to save my life because I would try to figure shit out the wrong way just to see if there was a pattern. I did okay, though. I came out with A's, but I can't just leave. I don't know, man. I don't know. Am I on the spectrum? I don't know. I don't even understand the spectrum because it's so limiting. It needs to be wider. All right. So let's go back to the calculator. I know there's going to be some of you that are going to be like, what the hell? Where were you going? What were you doing? Sorry, man. I'm sorry. Ten, 4, and 7/8, which is 10, 4, and 14. Boom. So you see, there's a 1/2 inch wrong here. The Construction Master in orange is a 1/2 inch wrong from true reality, because true reality is right here. Let me see here. From there to there is 16 inches. That's over to it. And they're a 1/2 inch short, which means they're, let's just figure out where they are. They're a 1/2 inch short. So we're going to move 1/2 inch this way. Doesn't look like much. Where is my dimension tool? There it is. Huh. Look at that. So starting at that first layout, how do I move this one? There we go. So because the um, construction master is a half inch shorter, then the rafter actually touches the hip at an extra half inch away from the end common. And and you don't notice it when you're running a 4-foot sheet down here. You don't even notice it. And I would always notice it when we got down to the smallest little jacks because they were actually so crooked that you could see it along the 4-foot edge of the rafter or the plywood. Too many terms. All right, so let's do this last one. If 11, boom. Yep. Okay. So now here's something to think about. This is on a 6 and 12. So if you're doing 12 and 12 or some other pitch, that little bit of difference is going to not just be exactly a half inch off. Like you can't just say, well, for every time that I have to use the construction master, I got to add a half inch to all my jacks because that's going to be pitch dependent. And it's going to be layout dependent because I'm 16 inch on center here. And if you were 24 inch on center, that would be different also. So anyways, that's how you calculate jacks. So in this roof, technically we have everything we need. You have your common, you have your tail. I will go shoot a picture of my 8 and 12 tail. I made it out of pressure treated 2x6 so that it would last forever. Somebody needs to go in and make, I don't know what they were called. When I was a kid, they were called Meccano, but I was in Canada at the time, so it probably was a different brand name. But somebody needs to make an adjustable tail out of parallelogram connected metal where you could adjust things and it would be all the pitches from whatever, 3 and 12 up. And there's just got to be a way. Somebody could 3D print something. I don't know. Maybe I'll do it. I don't know. But we would keep an 8 and 12. The houses we were doing were very similar overhangs. And so we always did an 8, a 9, a 10, a 12, a 16. And that was pretty much the pitches. And then we had like a tail pattern for a 12-inch overhang and a tail pattern for a 16-inch overhang. And we didn't go much beyond 16 down in south because we wanted to rip the soffit. They did closed soffit, and so we would rip plywood so we could get 3 pieces that are really close to 16. And we'd cut vent holes in them. And that was another thing was one builder goes, hey, can you guys like evenly space these vents? Because it looks kind of stupid if they're just random stuck in there. And that's an easy calculation too when you can take the whole overall. And then he says, I want them around 6 feet, every 6 feet. And so I came up with one of those, and that worked out perfect. So that the houses we framed looked really good. But now they got perforated, hardy, what's that, LP, Smart. They got all the brands come with this stuff already done. Bunch of little holes already drilled in. It's pretty cool. All right. So I hope that helped anybody. I hope I didn't really confuse you, but the variables that you need to know is how thick this is. Like if you're using an LVL that's 1 3/4 inch, that actually helps the construction master be more close because now you're bringing the face of the hip closer to that shorter jack. And so your jacks won't run as crooked. But if you did let's say you had a 3.5-inch ridge and an 1.5 hip and hip, well, now you're going to have to actually do some extra thinking about this, because you can't just use the calculator and push the jack button, because you'll be wrong. Because it's making its calculations based off of how far from center the face is, and then it's assuming it's the same down here, and that's just not right. Okay, well, this has gone on long enough. If you want me to put any of this in some kind of writing format, I can do that. Let's see. I'm gonna open something up over here. There's one thing that I will probably never share, because it was a lot of work to get it done. Let's see. I'm scrolling. We're scrolling. We're scrolling. That's not it. Oh, it could be this. Yeah. Let's open this up. So this is doable, and I would motivate you to go ahead and figure out how to do this on your own, because then it'll make sense to you. But let's do this. He said it was 24, 0, 0. Ridge thickness 1.5 inch, wall thickness 5.5 inch, overhang. Would we make our overhang 20? Subfascia 1.5 inch. It's going to be a 6 and 12, 6 and 12. Hip thickness 1.5. Rafter type, layout, boom. Okay, so we figured all this out, and you only have to enter it in the green areas. So yeah, I won't be giving this away, because you know what will happen? Somebody will use this and make a mistake, and then they're gonna, well, I did it the way you said. It's like, okay, no, you figure out your own way, and then whatever works for you. So I was able to figure out a way to make it do feet inch 16ths, and that's like way back here on one of these other tabbed things. It does all that, and then it brings back the value. So the rafter 13.4 and right here, 13.4 and 3/16 right there, 13.4 and 3/16 right here. The tail 1, 8, and 11, and there's the tail 1, 8, and 11. End common's the same as the main common, because both pitches. So this is set up to do irregular pitches, or like we used to say in the olden days, bastard hips. But this has way more information too. So some people just cut the hip, put this diamond plumb cut on. We called it a diamond because it made this point, and then it's a plumb cut. But the super pros, they'll run their saw down both sides of this, and they'll cut the backing bevel on the top of the hip. And in that way, that top bevel edge down the middle actually rides right to the top of the ridge right there. If you don't do that, you have to drop the hip a little bit. And then the other thing is you have to cut the bottom the same amount so that the whole hip drops. And I've got it in here as a calculation. Let's see. If you're going to do it dropped, there's your height above plate for the dropped hip. Otherwise, your height above plate matches the rafters, which is nice. If you've got a 6-inch hap or a 6 3/8, then your hip does the same exact thing. You don't have to drop it. And that's ripping the backing angle. So the backing angle is in here somewhere, 18.43 degrees. And the reason why I have a low side, high side is because if I had gone with like a 6 and 12 and a 12 and 12, then you're going to have a low pitch side, a high pitch side, and then it'll calculate all this stuff for you. So this is how I used to show up to go to work. I do this all on a calculator, but now it's in Excel. So that took a little while because Excel is a little bit complicated for doing some of this stuff. Because it lives in radians, and you have to convert everything to degrees, and it's just a bunch of hooey. See, this is what happens. Daylight savings happens, and I'm completely out to lunch. What else is cool in here? So let's see. Where's our hip? Our hip length to the corner, 17, 10, and 14. 17, 10, 14. Do I have it all the way out? Maybe I have a hip tail. Oh, no. I'll tell you what. This is when you have two different pitches, the steeper pitch has to have the plate raised up so that your overhangs match, or you're going to have weird overhangs. So if you want the equalized overhangs, you end up bringing the hip over and raising the wall of the steeper pitch, and then it projects down the same horizontal distance as the lower pitch does. And that's what all these are for. So when you see all these zeros, it's only because we're doing 6 and 12 on both sides. Jacks. Here's your increment. 1, 5, 14. 1, 5, 14. And here's the rafter lengths. So 11, 10, 12. Ooh, the green one is right. The construction master is wrong. 10, 4, 14. 8, 10, 16. So 8, 10, 16. That's a hard thing for me to figure out in Excel. Is 16 over 16 is 1, and it should carry over and add 1 to the next column up. So that should say 8, 11, 0. But sometimes it doesn't. I don't know enough about programming to make that say, hey, if you're 16 over 16, kick it to the next number. Yeah, I'm sure it's doable, but not by me. And so there you go. There's the jacks. They're the same jacks here as here because they're both 6 and 12 mains and 6 and 12 ends. And if we had two different pitches, all this would be populated different. 45-degree bevel. What else? That's about it. So it's really cool. This is a really cool little thing. This is version 4. I've had to do some edits with it to make it, be accurate, but maybe someday. Tell you what, you just text me. Give me your deets. See these deets right here? Give me these deets. And I will fill this in, and I will send you a PDF of this, if that helps you. We might try that out. That'd be kind of cool. First like 10 people that request this will be free. I'll just help you. And then all I ask in return is, if it works, tell me it works. If it doesn't work, tell me what went wrong so I can make it work better. All right. I think this video is done. I think this is like an hour long, but I give the highest respect to Tim Uhler because just watch him. When he's right, he has every right to brag. And when he makes a mistake, he owns his mistakes instantly and with the utmost humility and a little bit of sense of humor. And I respect that so highly because it's a rare thing. So watch his videos and learn. And he has some snazzy, expensive tools, but he also has some cool things. Like he'll show you a jackass sawhorse that he builds out of plywood. Get the plans. They're like $6 or $7. I don't remember. You can contact the link that he provides and make your own. They're pretty awesome foldable sawhorses. I never would have thought about using plywood. Anyways, have a great one. I hope this video was helpful on how to calculate all this stuff. We can go more in depth, but now I'm going to go watch his video and see if I missed anything because this is how I do it. Once I got these numbers, I'm off to the races. Yeah, like this here, 11, 11 and a quarter is to the face. So you hook this end, you come 11, 11 and a quarter, and that's to the layout. And then you go the rafter thickness over. And now you've got where your main common start. Now, some people are going to start at this end over here and then go multiples from your sheathing sticking over your overhang and then breaking 8 feet, 16 feet, whatever. And then you're going to have like some kind of close layout, or you're going to not follow the calculated layout. So what I do is something like this. I'm going to go ahead and make this all correct so I can start with my plywood. And my plywood might even hang long. But I'm going to make sure I can calculate all these, build these. And then my first set of main commons is on a 16-inch layout from this jack. And then I can just keep going. And then if I have a close layout over here, I don't really care. Because, I'm just going to stick it out there and either pop a line and cut it off up there, or have whoever's on the ground cut it. And now with track saws, man, guys can cut some really nice stuff. You can even bevel cut your plywood to go up on your beveled hips and just make it awesome. All right, I'm shutting her down now.